Hello. So this video is dedicated to a special person, number 13. So I initiated to make a diagnostic tests before running the regression analysis. So first of all, I import the data. Let me import the data. What's this data that I was using? No, it's not that data. Let me select another data. It was on my desktop yesterday. We saved it, I guess. Yes, this is the data I was using. Now it will just come up. Yes, here we go. Import it. Then I'm gonna declare data to be panel data. As you can see, it's strongly balanced. Then I'm gonna create, actually what I need to do here, it's basically to test diagnostic test. First of all, I will run, but let me see the statistics, summarize of all my variables that I'm gonna be using. Yeah, is it being recorded? Yeah, it's been recorded to be on safe side. So I'm gonna use these values. Oh, my variable has not been created. Generate. It's log of revenue from the business activities divided by energy use emissions. Okay. Create it. And I need to create a general board. It's log of board size. That I have it here. Where is it? Here we go. Now I'm gonna put the summary statistics again back. Let me add one more variable to just no. What I can see here, is there any outliers? Yes, operating margin. Look at it. It's minus 74,000, 21,000. It's a very big outlier, so it's not a good sign. So there's a problem with the data. And the loan growth here as well. Research development expenses as well. It's a percentage, but you see what it shows. So there is a big difference. And emission score, it's okay, from 0 to 99%. ESG score from 2 to 93%. So we need to basically do vinsorization, which you know already, number 13. Now I will get these values, put it here. Let me just raise it. So I did the vinsorization. Now, if I run the summary statistics again, as you can see, the data is perfect. Like there is no outliers. Perfect. Now I can work out my variables. First, I will run the regression. Regress. Then I'm gonna check for multicollinearity. Multicollinearity, it's a correlation between the variables, independent variables, which is not really advisable. So if the acceptable range from up to 10, if it's less than 10, it's okay, but the best range is less than 5. So as you can see, your results are perfect. So basically you run the regression. I'll put this coding here so that you can use it, okay? Diagnostic tests, multicollinearity test So this is I put the values in here. I put the regress. Then after that, you do start with, and once you have it here, multicollinearity, okay. Okay, this is the coding, and you get the start with. If it's less than 5, it's the best range that you could have, that you don't have any multicollinearity issue. This is the first thing. Then I move to check heteroscedasticity. So for heteroscedasticity, I need to run a fixed effect like xtrec. And heteroscedasticity is the variance of the error terms. If it's a highly variated, then it's not really good. So the best choice is they should be homoscedastic, means that the variance of the error terms should be constant. So fixed effect, and I just type xt-test 3. Okay. If the p-value less than 1% or 5 or 10%, then there is a heteroscedasticity, so which is not really good. So we can see there is a p-value, it's less than 1 or 5 or 10%, then it means that it's a big issue. So I'm going to copy again this one. Okay. Heteroscedasticity. Heteroscedasticity test. Okay. So I'm going to put the values. First, you run this. Then you run xt test 3. In case if you don't have it, let's say in your starter, what you can do, it's basically make it like this. xt test 3. Use this code and it will install it if you don't have it in your starter. It should be there, but in case, to be on safe side, so I'll put it in bracket here, in case you don't have it, okay? In case you don't have it in starter. So use this. Okay, that's what we have it. Then we move another issue, it's autocorrelation. Autocorrelation. So basically, to test the autocorrelation, you don't have to run fixed effect, you just run xt serial without this fixed effect. Again, if the p-value chi-square is less than 0 or is less than 1% or 5 or 10%, then there is autocorrelation. Autocorrelation is when the error terms are highly correlated, which is not really good for the estimation. Okay, no observation because we have some of the variables are very low, like ESG score. So if you remove this ESG and L board, because from the statistics, from descriptive statistics, I showed you that there is an issue with the observations. Okay, it's very, very small, even less than 2000. So if you change this one to emission score, let's say, just to be on safe side, xt serial, maybe it will work. I don't know. I didn't try it, but it might work. Yes, it worked. Perfect. So one alternative, change your ESG score to emission score because it still measures half of the ESG scoring. Like it represents, it can be proxied as ESG score. So it's advisable for you to use this one. Okay. So there is autocorrelation. So I would strongly advise you to use, instead of ESG score, use the emission score, because the number of observations are very, very small in ESG score. But emission score could really good replace it. You can still call it as ESG score because it's just part of it. No problem. So again, what you do, you just copy it. I'll put it here, okay? Come back here. Autocorrelation test. Autocorrelation test. Again, if it's less than 1 or 5 or 10%, Then there is autocorrelation. So okay, here we go. The diagnostic test, this heteroscedasticity, this autocorrelation, and this is cross-sectional dependence. Now, 3 tests we did it. Now, the last one is the cross-sectional dependence. The issue with the cross-sectional dependence, normally what we do here, it's basically we run again xtrec, okay? We run again xtrec, like this, we run it. And if you wanted to use, let's say, Pesaran one, xt, I think it's like this. We'll have some error because Pesaran is basically for strongly balanced panel data. But in your case, you don't have strongly balanced panel data, then it would be advised for you to use another way of approaching, like more advanced, where you have to make some additional installation. But look here, it will give you error. You see? The panel is highly unbalanced, not enough common observation across the panel. So I have the same situation with the banking industry, so I don't use it. So what I do it here, so basically you'll have to install additional instrument that could help you to use it. So that is this, or what I mean? The second, before I did it already installed, if I have it here. Here. So this one. Net install xtcd2 from this website, okay? It will install it if you press enter. I already did it, okay? So it's already, if it's not verified, not already installed. All files already exist and are up to date, okay? Then what do you do next? Again, you're running the xtrec. You're running the xtrec. You're running the xtrec, okay? And next step, you should do predict any name. Let's say UHAT, okay? UHAT 1 or just UHAT and error terms. So what is UHAT? UHAT is the guy who has created this coding for highly unbalanced panel data to do the cross-sectional dependence. So, okay, so I did it. So in here on the right side, it created here, as you can see here, it created. So I will give you all these codings. Don't worry, you'll have chances to repeat it, replicate it. Okay, now it's here, as you can see here. This UHAT. So I'm going to be using it. So what I do here, it's basically xt. Once it has been installed, xtcd to UHAT. So if you run it, it should give you basically the results of the cross-sectional dependence. Actually, there will be 4 methods used. You see, unbalanced panel detected, test adjusted. Now it works. It will take some time to come up with a certain value. Here we go. Okay, here let me explain you. As you can see, there are 4 tests have been done. Okay, the first is Pesaran. The other one it's a bit advanced of the Pesaran. So this 2 contradicts with this 2. So last 2 things they say that it is highly contradicting each other. So simply speaking, which one are more reliable? The last 2 are more reliable. But how are you going to be interpreting this result? Again, if the p-value is less than 1 or 5 or 10%, then there is a cross-sectional dependence. The last 2 things are advanced level that even detects the weak dependence if it presents, okay? Even it detects the weak presence. So this cross-sectional dependence was assessed using the multiple tests in here. Providing the framework. The first, the Pesaran CD test, which is 0.87, and CD-WE, it's 0.59. Test failed to reject the null hypothesis of weak dependence. However, they both power enhanced. And cross-sectional dependence W plus statistic and pass around XYCD star test shows you that there is statistical significant cross-sectional dependence. So because CD W plus and CD star are more powerful in the presence of unbalanced panels, and they're kind of latent to factors the structures. So we conclude that this data exhibits strong cross-sectional dependence. So therefore, estimators robust to cross-sectional dependence. So we can use Driscoll Kraay, we can use panel corrective standard error, and to solve it. So you better to solve that one, to use that in that case. And regarding the country heterogeneity, you have to come up with the country IDs and use that country IDs in your dataset. Again, what is matter in your dataset is you have highly unbalanced for ESG score. I recommend you to use emission score instead of ESG score first. And second thing, you add country 2. So basically what you will be doing is for your regression, I would suggest you to do the following, but let me just record this final things and put it into Word file so that you'll be able to follow it. So this, I will copy it and paste it. Then you run this. Okay, once you installed it, here. Then I put it here. You run it, okay? And we have another functions, predict, UHAT, it created, okay? And yes. So I copy it and paste it here. And then you get the results. Okay, I will save it and I'll share it with you this. So this is all for things that you did it. So you can run the fix effect, but fix effect will not cover it. Additionally, you can run Driscoll Kraay for robustness check. Okay, run the fix effect to but the best thing in Driscoll Kraay, so basically what you need to do, so let me just copy it, this one, and paste it. So it's here. Now, the issue in here, you have that you cannot run just normal fix effect. It can solve the heteroscedasticity, autocorrelation, but not cross-sectional dependence. So what you need to do, you need to just run XTCSS. It's a Driscoll Kraay with a fix effect firm level that will capture the following. It will capture country heterogeneity, that is constant over time, which includes like legal system, culture, long-run regulatory environmental things, and structural country differences that don't change over time, and so on. So basically you're controlling. However, you need to control for the time effect too. So there's a time heterogeneity should be controlled as well to make your data purely free of any errors. Okay, so that's what we have it. Oh, it doesn't give me any mistakes. Let me SCC XTSCC, if I'm not mistaken. Yes, hope it works. Factor variable and time set. Okay, it doesn't work. Then let me just. Okay, now worked. Now it worked. We controlled. Perfect. This is the result you get it. So I will be giving you this. So use this one, and maybe we can. So you can work this one and use some fixed effect for robustness check as well. Okay. So that using this model, it controls country heterogeneity, time heterogeneity. It controls all these issues that you have it, that we have found it. Hope it worked and helped you.